Okay, remember guys, I want to recall today is the last day to send me the answer and the test number one. No, sorry. It's the first, the last day to submit your test online. The test on paper I grade, but I am waiting to post the information in Canvas for the test uh, online. So when I have both, I posted the completely grade the both tests and include the extra credit for the homework and the extra credit for my subscription in the YouTube channel. Okay? But today, no excuse, another day is late. Okay, so we continue study the polynomial. Are you ready to pay attention? Yes or no? Ready, pay attention? Let me check attendance. Okay, yeah, increasing the student. Okay, ready to pay attention? Okay, entonces I want to do one more example. I bring today a lot of examples. In this example, you can see a new thing, So little by little, you see new information about polynomial. Entonces now, suppose que one important thing, number one, to analyze in the graph of the polynomial, because the question is do the graph, no? Is the end behavior expression. End behavior expression for the f of x. Remember, you take the dominant monomial, que es x to the 6, because I know that x to the 6 increasing factor, no? Is x to the 6 power, increasing factor. Entonces, x to the 6, and you know that when the exponent is even, and when the coefficient, que by the way is 1, is positive, the end behavior look like that. I don't know exactly what happened in the middle, it's not important, but the end behavior is when the x approaches to infinity, what is the tendency of the y. Entonces es like right up and left up also. Number two is, in order to do the graph of the polynomial, you determine the y-intercept. It's important. And the formula for the y-intercept is evaluate the function in C. This is the formula. Keep in mind. Plug it in. Es obvio que es 0 to the 6 minus 3 times 0 to the 4 minus 4 times 0 to the second is 0. Therefore, the point 0, 0, well, it's a y-intercept, but it's also x-intercept because include the x-axis. Okay, it's a coincidence, sometimes happen, not always, but in this case. The third step is find the x-intercept. It's the most important and complicated part. The formula is f of x equal to 0. Good. And to solving this polynomial equation, so basically we have x to the 6 power minus 3x to the 4 power minus 4x to the second power. You enforce it to be equal to 0. In this moment, we have polynomial equation, and you find the GCF. Obviously, GCF in this case is x squared. You factor out x squared parentheses x to the 4 power minus 3x to the second minus 4 equal to 0. Oh, and this is easy because We continue factorization, in this case trinomial factorization. Okay, is you break it down into parentheses. This is x to the second, this is square root of this guy. And the combination that open the door is 4 and 1. 4 and 1 because 4 times 1 is 4 and 4 minus 1 is 3. What sign? Negative 4, positive 3. Now, you see now the differences of the square. It's another technique. We apply GCF, binomial, and difference of a square. X squared is two parentheses now open. X square root 4 is 2 plus or minus. And this is impossible factorization because it's prime expression. I know. I need to remember something. The sum of a square obviously is prime expression. Impossible factorization. And leave it like that. This is my expression. Now you separate using the zero factor property. Zero factor property. You put each factor is this, and this equal to 0. Okay. So x equals 0. X squared, sorry, equal to 0 means okay, x is equal to 0 is one solution. It's expecting because remember when you found the y-intercept is also x equals 0, so 0, 0. Now this answer we expect. And very, very important to understand in this case the multiplicity is 0, but the multiplicity is 2. Because actually, this is a quadratic equation, no? So we have two solutions, is 0 and 0. But the correct way to indicate this, you put semicolon, multiplicity 2. Let me explain clear now. What is that? And we continue. The second factor is x plus 2 equals 0. That means that x is negative 2. Of course, multiplicity 1, because we have no exponent here. So negative 2 is valid only one time, no 2. 0, no, 0 is 2. And x minus 1, minus 2, sorry, equals 0 is x equals positive 2. Likewise, multiplicity 1. And the last is prime expression, so a reducible quadratic expression. This is called, guys, another name to this is irreducible quadratic expression. And let's see why it's irreducible. Now you see now. You copy x squared plus 1 equal to 0. Oh, but this is quadratic equation. This was quadratic, this was linear, and this is again is quadratic. But the solution is easy. Is you move 1 to the right hand side, you apply square root both sides. This is x, and we have plus and minus sign. This is the reason it's irreducible. Because the solution of the any quadratic irreducible expression is or complex or imaginary. So in general, it's complex. In this case, a particular pure imaginary. And the complex always is coming by pairs of conjugate number. Okay. What more else? Well, in that case, see, I want to verify the symmetry of this graphic, symmetric of the you investigate if the function is or even function, que is symmetry, of course, or odd function, that's another kind of symmetric, or no, entonces neither. To investigate this idea, well, you take the function, you make a reflection. This kind of reflection always, you put the negative one inside the parenthesis. And let's see what happened. Let's see what happened. So now, if you take the original function, okay, okay, it's given here at the beginning, and you are doing the reflection. Let's do it here. I am doing the reflection. Okay, so evaluate f and minus x. I make a reflection. You replace x for negative x, so we have negative x to the 6th power. Be careful with the signs. Minus 3, minus x to the 4th power, minus 4, minus x. Yeah, mistake here. This 4th power is outside. It's obvious. Because the only thing I did was replace x for negative x. And you know very well that when the exponent is even number, is positive. Doesn't change. Now, when you compare this and the original, it stays the same, doesn't change, therefore, it's a clear even function. See, it's even function, guys. This is extremely important to understand. That means that our graph of the polynomial is symmetric with respect the y-axis. So the y-axis behave as a mirror, and the graph you see when we finish is perfectly symmetric with respect to the y-axis. Entonces I forgot super important idea. I forgot. Sorry. And the exponent set, we have two kinds of zeros. Remember, exponent set is synonymous in the language of polynomial to see zeros. The zero of the polynomial represent the exponent set. Of course, represent the real exponent set. The imaginary no. The imaginary never you see. This is invisible. This is a ghost. However, it's important to understand that our graph look like that. Look, this is the graph. After we see in this. First of all, a behavior. Just like that. Secondly, y intercept is 0, 0. I plot this one. 0, 0. Okay, where is this? Here. And the x-intercept is also 0, que es 0, 0. And this is negative 2, 0. I forgot to say that. This is negative 2, 0. I plot that. 1, 2, negative 2, 0. And positive 2, 0. Okay. 1, 2. I plot that. This is 2. Positive 2. This is the 3 zeros, real zero of this polynomial. We have two more, que es complex, imaginary, but you don't see here, never in the rectangle. But actually, how many zeros? How many zeros has Our polynomial, how many zero? Well, that depending of the degree. The original polynomial degree is 6. Look, degree, look at the end behavior, degree of this polynomial is 6. So they are one super important I want to write now when I finish this problem. One super important theorem in algebra que say que si f of x is a polynomial function of the degree m, general m, in this case is 6, f of x has 6 zero, and you count multiplicity and complex zero. Okay, so basically, how many zero? We have 6. Where come from this 6? 0. Bueno, is the zeros of this polynomial is 0 and 0. Okay, you, when the multiplicity is 2, you consider 2 times. Minus 2, real. Positive 2, real. Okay, positive 2. And we have two complicates, I and negative I. 1, 2, 3, 4, 5, and 6. So the theorem say, see f of x is a polynomial function, polynomial function. A function. This function has exactly the same zero of the degree. The problem is that these and these are invisible in the rectangular, the classical R2 rectangular coordinate system. And 0 is, overlap in the same. So the conclusion, my graph look like that. Look, scan behavior, cross here, touch here, and cross here. Remember, my graph is not good. My graph is not good because the polynomial never have that situation. So it's a smooth curve, smooth like that. Okay, and this is smooth also. Never have a corner, no corner, smooth. But the most important I want to say now is that when the multiplicity of the zero is even, always happen that the graph of the polynomial touch the x-axis. Touch the x-axis, no cross. However, when the multiplicity is odd like that, or like that, the graph cross. So this is the perfect identification. Unlike the multiplicity, see it's odd cross, look cross, and it's no cross. It's like a bound, so it's touch it, but go back in the same direction, in the opposite direction. No cross, no continuity, or like that. Okay, so now this problem illustrates a little bit, not too much, every possibility of the polynomial, no? But this problem was easy because we can find the zero of the polynomial by the technique of a factorization. You apply GCF, trinomial, difference of a square, nice. But not always is possible doing this. So what now? Factorization is good, but it's weak. So we need to find another more sophisticated technique to find the zero of the polynomial. Okay, I want to explain in a few seconds. Any questions so far? Do you understand very well everything I explained or no? What part is confused? Come on. Come on, I want to hear questions. It's my pleasure.
I understand.
Everything?
Yes.
Cool. Okay, so let me try to explain another sophisticated technique and summarize some important theorem can help me to understand, visualize the zero of the polynomial. So the most complicated part in the polynomial function is find the zeros. And this example we were doing before was easy by factorization, but no, always. Now I want to recall long division. Long division of polynomial, and of course the zero factor theorem. Okay, let me recall quickly long division. Finally, we ending in zero factor theorem. Okay, let me recall. Suppose you have 2x squared plus 3x minus 14 divided by x minus 2. Okay, division. Polynomial degree 2, the degree of that polynomial is 2. This guy, the reason is clear, this 2, no? And the degree of this polynomial is 1. Because here we have invisible exponent is 1. Entonces, bueno, we can, why not? We apply the typical format for the long division. You put the dividend, this is dividend inside the box. 2x squared plus 3x minus 14, and this is the divisor outside the box, x minus 2. Okay, ready to make long division. So I need to find one expression. I need to find one expression can multiply by this. Suppose 2x. You multiply this times this. When you multiply 2x times x is 2x squared. Exactly I need identical expression. Now collateral, you multiply this times this, que is negative 4x. Do you see that? Now, subtraction. To subtracting, I need to change the sign. Minus plus. This is a classic, guys. Division is an algorithm que es sistemática, multiplication, subtraction, multiplication, subtraction, multiplication, subtraction, multiplication, subtraction. You are doing division, always. Okay, entonces this is 0. So we cancel out all 0. Some people prefer cross like that. All 0. And this is 7. 7, 3 plus 4 is 7x, no? I finish, no. How do you know when you finish? When I finish, when the degree of this, que es the divisor, que es 1, should be greater than the degree of the hypothetical remainder. Degree is 1, because it's x to the 1 power. Entonces, es obvio que no. We continue. We continue until degree is 0. And degree 0 means no x. So the x is missing, no? Okay, so we continue, bring down 14. I bring down negative 14. Okay, I continue. I try to find one expression que multiply the first one, give me 7. Oh, it's obvious que 7. It's 7 because when you multiply 7 times x is 7x. Oh, cool. It's exactly I need. And when you multiply 7 and negative 2 is negative 14. By subtracting, change the sign, and the remainder is 0. Okay. So what is the answer, Professor? Well, the answer is the quotient. The answer is the quotient. And the quotient is that part. Okay. The answer is the quotient, que es that part. Wait. What is the conclusion? I don't understand very well. The conclusion is we discover one factor of the polynomial, because you multiply, for example, you multiply x minus 2, get the divisor, multiply by 2x plus 7 in order to make backward. So I am doing x is 2x squared, outer, inner, 7, -4, and -14, no? And when you combine like down here, you have 2x squared plus 3x minus 14. Wow, fantastic. Entonces, I do the factorization, but without factorization. I did the factorization using long division. An important. Zero factor theorem. See, the remainder is 0. This guy is a factor of the polynomial. See, the remainder is no 0, of course, no factor of this. This is a 0 factor theorem. I want to explain different technique to guessing to get the factor of the theorem using division. But in my opinion, it's better using no long division. No. Well, long division we use it, yes. Long division we use it, but not always. We use a synthetic division. And synthetic division is using, not always, but when the degree of divisor is 1, is better. Degree of this is 1 is better. Therefore, you copy, look at the advantage and disadvantage. So long division is universal. We can use it always. Long division, not always. Synthetic division, not always, sorry. Only in the particular example in which the divisor is degree 1. But it's nice, it's easier. Okay? So what should I do? When you copy the coefficient of the dividend without x, no x anymore. 2, 3, and -14. Wow, I like that. Not necessarily copy x. And extremely important now, you copy divisor without x, of course, and opposite signs. And maybe you say, well, Professor, what is the reason? This opposite sign. Because you remember in long division, you need to subtract, and you change the sign, you change the sign. No, you change the sign in synthetic division one time. See, our divisor is x minus 2, you put positive 2, it's the opposite sign of this. See, the divisor is maybe in another example, you see a lot of today, x plus 2, this is minus 2, opposite sign. Okay, so what is the procedure in long division? One of the procedures is easy. You bring down without do anything the first number, 2. A multiplication, 2 times 2 is 4. And we combine 3 plus 4, 7. A multiplication again, 7 times 2, 14. A -14 and positive 14 is 0, and this is the remainder exactly the same of this. And the answer of the synthetic division is that part. The last row, we have 1 row, 2 row. The third row is the answer in which you consider this is x to the 0 and this is x to the 1. In conclusion is 2x plus 7. Boom. Exactly the same of this. Do you see? Entonces, never we use in long division. Bueno, you use in long division when you have one scenario in which the degree here is not 1. Degree 2, degree 3, and the divisor. Pero the majority of cases, no. Okay. So remember, we are doing the factorization using basically, guys, the combination of the division, using synthetic division and factorization. So factorization, no completely discard. Factorization is one tool. I know disadvantage and advantage of the factorization. Okay, okay. I respect that. However, we're using like a extra tools. Let's see example of the scientific division and scientific division and factorization maybe both. Suppose this f of x. This is example one of this section que is about zero factor theorem. No? Suppose x cubic minus 6 x squared plus 11 x minus 6. Okay, okay, okay. So, see, I try to find the zeros using the traditional way of the factorization. I am totally lost. Suppose that I try to solve in this equation using only factorization. And I suppose using my imagination that this is by grouping, no? This couple and this couple. The great common factor in this couple is x squared. We have x minus 6, and we have no common factor here. Maybe another combination, but no, you never get that. Because it's impossible. It's impossible. Now, however, doing the synthetic division, maybe you get that. Okay. So now I copy the format for the synthetic division. You copy 1 minus 6, 11, and minus 6. Get the coefficient here. 1, negative 6, 11, and negative 6. And you try different values. This is the challenge. The challenge is discover what is the value. Don't worry, I explain different technique to analyze this. After that, only you pay attention. What is the procedure you can apply? And after I explain another complementary theorem and technique to make easy. And also you have Desmos. No? Okay, Desmos is fantastic, no? It's not 100% the truth, but give me a clue. Okay, so we have scientific division, new technique. We have Desmos and another complementary theorem that I want to explain after that. I know the answer because I did before, no? Because I tried with the one. Boom. The most important is know where come from this one. After you see more clear. You know, what is the procedure that I apply when I put this one? Of course, I get division. You bring down this one, don't do anything, just bring down, copy, paste, and multiplication. 1 times 1. Right? And you combine, this is negative 5. And one more time, multiply is negative 5 here. Cool. And now we combine is 6 positive, and one more time, multiply 6 times 1, positive 6, and the remainder is 0. Immediately, you see that the remainder is 0. When you finish the synthetic division, you can affirm que x equal 1 is a 0 of that polynomial que is equivalent to say somehow que the factor x minus 1 belong to the factorization of the trinomial without do factorization using long division or synthetic, sorry, division. Do you see that?
Yes.
Excellent. Now, I can continue. I want to explain two different ways. I can continue another value. I know, okay, what is the value? Suppose que es 2. So I create one example easy, get 1, 2, 3, the factors, because the degree of D is 3, no? Okay, no, I suppose que I don't know. Bring down one, bang. Multiplication is 2. Subtracting is minus 3. And minus 3 times 2 is minus 6. Again, remain the 0. Therefore, the x equal to is a 0 of this polynomial. Therefore, the factorization is x minus 2. And the factorization, you know, is completed opposite sign. It's clear, no? Because the factor x minus 2, when you force it to be 0, is because x is equal to. So there are two equivalent ways to express the same idea. Or you express x equal to, or you express que the factor is x minus 2, because of the 0 factor. And that's it. Another simple division, professor, because we have 3 0. No, because the last expression, the last row, is x to the 0 and x to the 1. Therefore, x equal 3 is equivalent to say the factor x minus 3. So basically, this polynomial, the factorization is 3 parentheses, x, 1, 2, 3, minus, minus, minus. You multiply, of course, it's a little bit long, the multiplication, because you select by couple, you select, for example, you over here, and you foil, and the answer of this foil, you select with the another third factor, and you foil again. And we come back at the beginning. This idea is clear or no? Entonces, in this moment, see, everything is clear. You let me know if it's clear, guys. It's clear or not? It's clear or not?
Yes.
Okay. As this is clear, I want to take advantage to show you the graph of this polynomial in Desmos. Entonces, one fantastic way. Let me see what's going on. Yeah, I understand. One fantastic way. Let me share the Desmos screen here. Switching to Desmos. Do you see Desmos now? Do you see?
Yes. Yes.
This is example 4. Yes, sure. This is example 4. Look at that. Example 4 is x cubed minus 6x squared plus 11x minus 6. The graph looks like that. Boom. Look at the zeros. The 0 is 1, 2, 3. I also illustrate the y and z is too easy. The y and z you obtain when you replace x for 0 is obvious and negative 6. Now we have 3 x in a z and 1 y in a z. It's clear, right? Clear. It's clear or no?
Yeah.
Yes.
Let me try another example. Oh yes, that one is nice. Okay, I have in the paper here, I copy. And after we switch into this. Look. Whiteboard. Share. Whiteboard. Do you see whiteboard?
Yes.
Okay, let's move on to this example is 2. X cubed minus 3 x squared minus 11 x plus 6. Okay. One fantastic way is you plot this in Desmos. and decimal give me no 100% of the solutions, but give me some solutions. But no, okay. So let's do it by scientific division. Scientific division, example. I copy this. It's 2 minus 3 minus 11 and 6. Entonces now, you see in decimals, you can see in decimals what is the number that you plug in here, the divisor, no? Okay. Let me try in decimals. In this moment, I open decimals, I put the polynomial in decimals. Okay. I suppose you see this one, no? No?
Yes. Yes.
It's this. 2x cubed minus 3x squared minus 11x plus 6. Boom. Here I do the graph. By the way, I select green color. Okay. I see 1, 0, and 3. I see 1, 0, and negative 2. Yeah, I see 1, 0, and 0.5. We are decimal. It's okay. I need at least 1 because the degree of our polynomial is 3. When you are doing the first, scientific division, the degree is reduced from 3 to 2. And from 2 is easy because you can apply maybe quadratic formula. Just there's a quadratic equation. But okay, either way, let's do it in either way. Suppose. I come back again to say, I know that 3 is a good candidate to start or negative 2. I don't like 0.5. No, I don't like. I avoid, for the moment, I avoid fractions. So we come back to the whiteboard, no? Entonces es 3, no? Es 3. Pero es positive 3, no? Es positive 3 de 0. I put positive 3. Remember, the opposite sign is with the factor. So I suppose the supposition looking decimals was que at x equal 3 is 0, que es equivalent to say que x minus 3 factor belong to the factorization of this. Oh, perfect. I bring down to multiplication is 6, subtraction is 3 positive, multiplication 3 times 3 is 9, subtraction is minus 2, and multiplication is minus 6. Cool, 0 remainder. Therefore, conclusion, this conclusion I want to write here. This is important. You organize your work in that way. Zeros and factor. Okay, I investigate doing this entire division, get add x equal 3, get the factor x minus 3 belong to the factorization. Cool? Now I see in decimal also minus 2. Let me try minus 2. Bring down to 2 times 2 is 4, negative 4. Now subtraction here is negative 1. Multiplication is positive. It's 0 again. Therefore, I investigate at x equal minus 2, because the factor is x plus 2. Do you see the opposite sign between 0 and factors? Cool. Now, I need to do one more. No more, because I know that this is x to the 0 and this is x to the 1. So our last factor is 2x minus 1. 2x minus 1. Que es equivalent to say x equal, let me see, 2x minus 1 equals 0. So for x, 2x equal 1, divided by 2, Why do x is 1 half? Okay, it's add x equal 1 half. This is the zero, the collection of the zero, this polynomial, and this is the collection of the factors. For sure, 100%, I guarantee you that the factorization is 3 factors, and the factor is in either order because it's multiplication. This is really amazing, right? Yes or no?
Yes.
Okay, so after we continue doing another problem, I propose you discussing in detail some theorem that is extremely important. Number one, this is the collection of the theorem behind this idea for the zero of the polynomial. No? The first one say if the function f of x is a polynomial, function, of course, we are talking about function of degree m, I call in general m, that means imply f of x has m zeros that include is counted multiplicity. Remember multiplicity when the 1 0 is repeated. You count 2 times or 3 times, depending on the multiplicity, and the complex. And the complex or imaginary case complex zeros. Okay, this idea is clear. It's clear, right? This idea is super clear, right? Super clear, right? When you put in the test, when the something assignment polynomial degree 3, we expect 3 0. Oh, include, of course, real repetitions, yes, multiplicity, or complex. We have another theorem, important. If f of x is a polynomial again, function, of course, whose coefficients as used to be are real. You never see in the coefficients say I numbers. If, comma, if 1 0 0 1 is complex a plus ib, include real part and imaginary part, then we have another 0 2 que es a minus ib. Wow, it's also 0. And the technical name of this guy is a conjugate. So the complex is coming by couple. So it's totally impossible to see. We have 3 complex. No, or 2, or 4, or 6, even. And they are coming by couple of conjugates. Suppose que it's given clear like a water, que 5 plus 3i is 0 of the agua polynomial. Okay, so you infer directly, it's a fact, it's true, que 5 minus 3i, que ese conjugate is also 0 of that polynomial. Clear? Clear this idea?
Yes.
Okay. And we have one third theorem, very, very important, very important. Number 3. que es the teorema of the rational zero. Rational zero theorem. Okay, rational zero theorem. This theorem I don't like too much because do not guarantee 100% the effectivity of the truth. But give me a clue, you know, give me a clue. I prefer Desmos, pero this is when this is created in the antique mathematics que have no internet, I have no graphical calculator. But it's okay. I need it's another clue. Okay, suppose que we have a polynomial, no? F of x. And the typical format of the polynomial is a sub m, x sub m, plus pam 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 pam, and the last guy is a sub 0, x sub 0. X sub 0 es obvio que es 1 because any number or expression raised to the 0 power 1. So this is the leading coefficient que es a sub m. A sub m is the leading coefficient, and this is the last coefficient que have no x. Let me call P like a sub 0, like this guy. This is P. And Q like a sub m. To investigate that the zero of the polynomial are rational. Rational means whole number 2, because 2 over 1 is a rational fraction, or 2/3 or 1/2, okay, but not radical 2. This is irrational. To have rational 0, one approximation is compute that formula, plus and minus P over Q. Let me illustrate using one example and you understand more clear. This is the, let me call something. This is the potential rational zeros. The frustrating part of this theorem is that you spend time and sometimes we have no. So the clue is given is invalid. This is not always happen, but sometimes happen. So this is a little bit frustrating. So this is not 100% true. If the computation of this give me a number, I try to verify, suppose I have no decimal, no? The synthetic division, this number is given in that formula, then I obtain result, nice, you are the best. Okay, suppose this example, suppose f of x, example of the rational zero theorem. Suppose f of x equal to x to the 4th power plus 5 x to the 3rd power minus 2 x to the 2nd power minus 11x minus 6. Cool. Minus 11x, sorry. Minus 6. Let me check it out. See I make a mistake. No, it's okay. Okay, so now I apply the zero factor theorem. Let me try to do my best. Zero factor theorem. I discover que P is 6. Look at that. Without sign. The sign is not important. I abstract. Yeah, I forgot to get minus. No, it's 6. Just 6. And Q2. And you apply the formula. The formula says plus or minus 6 over 2. And you are doing this division. No. We're doing different. We are doing like that. Look. You discover any possibility of 6. Any possibility of 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Let me try to give you the mnemonic device to understand this. Look, you multiply this and this, or positive or negative, and give me that. And you multiply this and this, and you get exactly 6. So it's all possibility, all factors of 6, que es 6 and 1, and 2 and 3. And 2, no, 2 is plus and minus 1, and plus and minus 2. You separate by comma. Now, after that, you using the formula, you create the list. And this list is the potential rational set. It's the list of the potential and rational set. How you create the list? Well, you, for example, there are many ways to do, but you divide this and this. Then you consider the first number. Guess what? I continue with the 1 in the denominator, and I include this, and this. It's obvious guess plus or minus 2, plus or minus 3, and plus or minus 6, because you are dividing by 1, does it stay the same? And that's it? No, no, because you forgot 2. So basically we have then, and now using the 2, and the 4 number in the numerator, it says plus or minus 1/2, 1 over 2, comma, plus or minus 2 divided by 2, again is 1, but 1 I include here. You can repeat. Yes, you can. It's no big deal, but I don't like because I include. What is the next? Well, the next is I did 2 divided by 2, 3 divided by 2, or 3 divided by 2 is not included inside the list. And 6 divided by 2 is 3, can I include? Boom, I finished my list. And this is my hypothetical potential rational set. I finished? No, no. This is just the beginning. I try to testing plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 3/2, using synthetic division. Of course, I know the answer very, very well. And to say, in order to don't waste the time, I try the synthetic division and the combination that I know gets good. In the real life, no. In the real life, you don't know anything, and you try. This is the format for the synthetic division. You copy 2, you copy 5, you copy -2, you copy -11, and you copy -6. Yeah, I try first, -1. You say, well, professor, why? Because I know the answer. Okay, and another fantastic way, you plot in Desmos, and that's what you see. You see, for example, que -1 worked, +1 no. No, it's not zero. Okay, and see, we have no internet, we have no computer in the 100 years before. So you are doing one by one, no? And synthetic division, and you see a word or doesn't work. How do you know the word or doesn't work? Because when you are doing the synthetic division and the remainder is 0, oh nice. This is a factor, this is 0. See, remainder no 0, this is no factor. Bring down 2. 2 times 1 is -2. Subtraction is 3. Multiplication is -3. -5. -5 and +5 is +5. -5 times -1 is +5. It's a -6. And -6 times -1 is +6. And the 0. Therefore, I copy here 0 and factor. I discover using synthetic division que x equal -1 is 0 of that polynomial. Therefore, the factor x plus 1 belongs to this polynomial. You see the opposite sign? -1 is a 0, +1 is a factor. Cool. We keep going. Yes, because our original polynomial degree 4. Look at that. Degree of this guy is 4. So when you are doing the first synthetic division, now we have degree 3 because this is x to the 0, x to the 1, x to the second, x to the third, yes? But this is crazy, doing by hand or factorization. No, no, no. We continue doing synthetic division. But what number I select? Well, I know the answer, guys. If the answer again, you try by -1. That means the -1 is a 0 multiplicity 2. Okay, so when you are doing the graph of this polynomial and -1, the curve touch the x-axis, no crossing. Pero no, no, I don't know. Let me try. So you bring down to multiplication 2 times -1 is -2. 3 minus 2 is 1. Multiplication is -1. This is -6. And -6 times -1 +6. Wow, fantastic. Remember, this is the important thing. See, I try another arbitrary number, you never get 0 here. Therefore, I investigate one more time, get x equal -1 is 0, and the factor is x plus 1 belongs to this. For sure, when they're doing the factorization of this polynomial, see, is the answer of the question. No, I don't know. You have x plus 1 squared. X plus 1 times ism. Okay? Entonces, in this moment, well, in this case, you convert degree 4, degree 3, degree 3, degree 2. In this moment, some people don't like to continue doing. Remember, guys, sorry. We're using -1 2 times. Entonces, now I want to using, in the next synthetic division, I want to using -2. Okay, is this. At least it is inside the list. The theorem is weak because do not guarantees that every potential are true, and also get the worst. Okay, exists. You try every combination and never you get 0 remainder, and this is normal. Not normal, pero happen. Could be happy. Okay, let me try the rest. It's 2 bring down to multiplication is -4, this is -3, multiplication is +6, and 0 remain. Therefore, I discover that x equals -2, and the factor is x plus 2 is a factor also. And the last is linear. 4, 3, 2, and 1 is x to the 0 power, and x to the 1. Conclusion, the factor is 2x minus 3, no? 2x minus 3. Okay, 2x minus 3 equal to 0 is 2x equal 3 divided by 2, both sides, x equal 3 half. Okay, nice. It's this guy. Look, positive. Belong to the list. At least 3 guys. 3 half. So the factorization the hour is x plus 1 2 times repetition repeated duplicity -1 and x plus 2. So you wait a second. Factorization is x plus 2. Let me see. Yeah, x plus 2, and the last factor is 2x minus 3. This factorization is equivalent to this. Equivalent. Okay. Suppose that when you are doing the graph of this polynomial, okay, we have a -1 here, -1. Guess this, we have a 0, no? We have a -2, another 0, and we have a 1.5, okay, 3 half, positive. This is 1, this is 2, in the middle here, 1.5, 3 half. 0, this is negative 1, comma 0, and this is negative 2, comma 0. And the end behavior of this polynomial end behavior expression is equal to x to the 4th power. Look at that, the leading coefficients. And this guarantees us the end behavior. The end behavior when the coefficient is even, when the exponent, is even and the coefficient is positive, look like that. That means right, up, left, up. Now, the multiplicity of this factor is 1. That means que cross. The multiplicity of this factor is, ¿qué es this? Is 1. Entonces, that is also cross. However, the multiplicity of this no is 2. Entonces, touch. I suppose that somehow this touch here was move and leave it. Just in case to see clear, let's see in decimal. I don't know if I do the graph in decimal. It's a specific example. But let me explain one more thing. One more thing that maybe is useful for you and you're working, because one possibility is, bueno, professor, entonces always we are doing synthetic division. No. Look at that. And then in that moment, in which I know very well that this answer is quadratic, degree 2, we can apply if you want. You can apply, so not necessarily doing this. You have degree 4 at the beginning. You are doing synthetic division. You convert degree 3. You are doing the second synthetic division. You convert degree 2. So that part I can ignore. I take in this equation. And you solve this. Wow, easy. Doing by quadratic equation. Quadratic equation or maybe factorization. Yeah, you can by factorization. In this case, easy. You multiply this and this is 12. I don't care the sign. 12. And one possible combination is 4 and 3. 4 times 3 is 12, and 4 minus 3 is 1. Entonces I copy 2x squared, is the first guy, plus 4x minus 3x minus 6 equal to 0. Now factorization by grouping, you have the couple red and the couple blue. And the pretty common factor in the couple red is 2x. We have x plus 2, no? And the great common factor in the couple blue is negative 3. And you have x plus 2. Just in case, to make sure that we are doing well with the sign, you multiply negative 3 and positive x and negative 3x, and negative 3 times positive 2 and negative 6. Cool. Now x plus 2 is a common factor, and we have 2x minus 3 equal to 0. Now you separate x plus 2 equal to 0. Obviously, as x equal minus 2, exactly, we get that here. And the second is 2x minus 3 equals 0, is x equal 3/2. I did by factorization in this case, but not necessary. You, for example, the student are found to the quadratic formula, you see A is 2, B is 1, and C is negative 6. And you apply our famous quadratic formula. Yeah, I suppose que we get the same answer. Let's do it quickly to make sure. Okay, B es 1. Entonces es minus 1 plus or minus square root 1 square que es 1 minus 4 multiplication by 2 que es 8 multiplication by negative 6 is C and 2 times 2 que es 4. We focus in the expression inside the radical is 1 plus, be careful with the sign, negative, negative, double negative become positive. This is 48, no? Because 4 times 2 is 8, 8 times 6, 48. It's 49. And the square root of 49 is 7. And so far, we have negative 1 plus or minus 7 divided by 4. I separate into pieces. Negative 1 plus 7 over 4. Negative 1 minus 7 over 4. Negative 1 plus 7 is 6 over 4, and lowest term 3 half. Bam, same answer. Same answer. And negative 1, negative 7 is negative 8. Divided by 4, negative 2. Same answer. Either way. Quadratic formula, because it's quadratic equation. You solve it in the way you prefer. But the thing I tried to explain was, you have equation degree 4. Using the zero potential rational zero theorem, you investigate the famous list. And the famous list, I need to guess in one by one who is the guy. Okay, guarantee zero remainder. And this is the factor, and this is the zero. Okay? This look like crazy, but no. Why no? Because in Desmos, you can see. Desmos is available for you 100%. It's your tool. This is our free, nice, beautiful graphic calculator. Let me try. This is probably no. See here. I don't do that. But I want to do. Why not? Okay, don't worry, be happy. Okay. Let me share the screen with Desmos. Switching. Desmos. Do you see Desmos? Do you see?
Okay. Yes.
Example 5, no. Let me see. No, 4 degree. Wow, it's 4 degree. Let me include like one new one. So look, let me show you one more. How you organize in your Desmos script different example. You click here in this plus. You include one folder, new folder. And this folder have no name. I want to call example 10. Oh, professor, but not good because you broken the sequence 1, 2, 3, 4, 5. No, you drag here and you put in the last place. And you press enter. Come, and you see it open a new line. And this new line is connecting by the folder when the 1, 2, 3 gray line is connecting this. Suppose I copy the question. No, I copy 2. I prefer using the keyboard for this one. 2 x to the 4 power 4 plus 5 x to the third power. No, mistake, erase. This is x to the third power. I forgot the x. Okay, minus 2 x squared directly here. Minus 11x minus 6. And you see now, the graph of the our polynomial. Okay? By coincidence, was the red color identical to the thing I try to do roughly, in the whiteboard. An important point are the famous point 3 half. Well, no, let me start from left to right. The famous point, open parenthesis with the point negative 2,0. Let me change to black color and put the label. Why not? This is my first zero. You can do sequential in the same line or in different. Either way, the variable go. Second is negative 1. Zero. By the way, negative 1,0 have multiplicity 2 because the factor belong x plus 1 squared. That is the reason it is 0 touch the x-axis because the multiplicity 2. And finally, the variable comma, parenthesis, 3 half, 1.5, either way, 1.5, comma 0. We have 3, 0. Actually, it's not 3, it's 4, because it's negative 2, 1 time, negative 1, 2 times, multiplicity, and 1.5, 1 time. End the story. Do you follow me?
Yes. Yes.
Excellent. Okay, so I want to explain another way to understand and visualize the zeros. This is a little bit weird. Let me try to explain using my best way. I need found first. I suppose que es in this paper. Boom. Yes. Okay. Another way can give me some idea. You know, it gets complicated, a little bit complicated. I'm guessing the zeros. I make share the whiteboard to explain the new technique. Whiteboard. Switching to whiteboard. Whiteboard, Microsoft whiteboard. Okay. So I want to erase this. Boom. Okay. Another rule, yes, it's a rule, is Descartes rule. Descartes rule. Descartes the rule of science is the technical names because the rule working with the science. So give me another clue to investigate the zero. Let me try to explain using an example because it's a little bit complicated. Suppose the function f of x equal x to the 5th power minus 6 x to the 4th power plus 12 x to the cubic power Let's see what I have here. Yeah. This is better. And this paper I have there. Okay, entonces minus 12 again is a coincidence. X to the 2nd power plus 11 x minus 6. Okay. This is degree free, 5. We expect in total 5 zeros. Include repetition, include complex, and include real, que is the most important. So what say the Descartes rule? The Descartes is an antique mathematician que discovered this rule. This rule look like science fictions. Descartes discovered the change of sign, the P, capital P, they call change of signs. The polynomial give me information, signs, and plural. Suppose this guy is positive and this guy is negative. We have one change sign. The card indicate using this symbol. And this is negative and positive. Another chain of sign. Another chain of sign. Another chain of sign. And another chain of sign. Wow, too much chain of sign. And the reason is because the first is positive, the second is negative. So always the sign is alternating, positive, negative, positive, negative, positive, negative. Okay, so now who's P? No, P is 5. Because we have 5 chain of sign in the polynomial. And this indicate us, okay, we have 5 or 3 or 1 positive real zeros. We're going from 3 and 1. I understand 5, but 3 and 1 I never understand. Why are you subtracting 2 always? Then you have 5 minus 2 is 3, and 3 minus 2 is 1, and 1 minus 2 is negative 1. This doesn't work because negative 1 have no sense, it's stupid. That we are finding the number of 0 to the negative 1 is crazy. So basically the number is super easy. You count how many chain of sign? 5. Descartes discovered that we have 5, or 5 minus 2 get 3, or 3 minus 2 get 1. Positive real 0. Okay. So what about the negative? Well, the negative, we are doing something different. We are doing a reflection. You replace and the original polynomial x for negative x. Let's do it because it's too easy. I know very, very, very well that when the spawning is odd, change the sign, but when the spawning is even, stay the same. So basically, it's minus x to the 5th power, minus 6 x to the 4th power, minus 12 x to the given power, minus 12 x to the 2nd power, plus no minus again, because it's exponent is 1, it's odd number, minus 11x, yeah, of course, minus 6. Okay, you see, and now, let me see now the number of chain of sign. I call capital M the number of chain of sign of the polynomial when you are doing reflection. We have no, look at that. It's a negative, stay the same, negative, never change sign. Let's see. That means our polynomial have no but negative real zero. So no negative real zeros. You understand this idea or no? Yes or no?
Yes.
You don't finish. This is the most important moment now. How you summarize this information. Because actually, professor, you explain that this original polynomial have 5 zeros. We discovered that we have or 5 positive or 3 positive, 1 negative. Say, and never we have negative zeros. And to say how many complex. So we create this table. We create this table to condensing the information. Condensing the information. Suppose, and the first here, 3, 3, 3, 3, maybe 3. And the first row, I investigate the positive. The positive real zero. And we have, unfortunately, 3 combinations, 5, 3, 1. And the second, always you put a negative. que yo investigué que no, zero. And the complex, let me go C. Well, the complex I know it's coming by couple, by pair. I have no sense to talking about 5 complex or 3 complex. No, it's 4 complex or 2 complex or 6 complex. No, 6 have no sense. And here total. And total I know que 5. 5 y es 5. So one possibility is that we have no complex because 5 plus 0 plus 0 is 5. Another possibility is that you have 2 complex because 3 plus 0 plus 2 is 5. Another possibility is 4. Of 1 plus 0 plus 4 is 5. Okay? Now, we investigate. Now, after that, okay, this combination is the good combination. But this is after. So this Descartes rule give me pre-analysis how look like the zero of the polynomial. Entonces we need to continue scientific division, we need to continue rational zero theorem list, the potential and different synthetic division until you get the answer, right? Okay, but let's do it. We finish this problem completely. Let me try, let's see if I have or no. Oh, yes, I have. Look. This is just the beginning. So in my opinion, my opinion is that the first thing you should do is put in decimals. Of course, you are smart. And after to prove me mathematically in the test online no, on paper, you send me, you are doing the rest of the analysis. No, see, but Descartes, he don't ask about Descartes, don't do that. Say one possibility to investigate, but it's okay. Okay, good. Entonces, let's do it. I have no idea. Suppose que I am antique mathematician. No, I am no antique. Try to using the technology. Entonces no, okay. Entonces I using Desmo, pero Desmo is the last moment. Illustrate you that we are the best. However, let me using the rational zero theorem. And remember the rational, the formula plus and minus P over Q. No? Okay, and P and our example is 6. Look at that. And Q in our example is 1 because we have no coefficients here. Entonces plus or minus 6 over 1. Oh, it's easy because when there's 1 here, it's only one combination. The plus or minus 1. We have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Entonces our famous list of the potential zero is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Always divided by 1, que 1, it's invisible. Now ready to start. Long division. Long division, no, scientific division. Typical format. Laura dice starting a call. Starting a call. Okay. It's already recording the video, eh? Let me see. Oh, yes. Nobody touch. Nice. Okay, so now I take in the original. Record. Okay. Is 1, negative 6, positive 12, negative 12, 11 positive, and negative 6. This is the original polynomial. And you now investigate, for example, the member in the list. Okay, I am guessing, pero no, I am not guessing because I did before this problem, no? I understand. Laura, I send I don't know if you know, I send in every lecture different link. So you can connect in I suppose that you don't see very well. You connected with the old link. Try to check in your email and connecting by the new link. Okay, so I did before. Yeah, I know. Okay, one is good. Positive one, positive one, positive one. Let me make it soon. Bring down one. Multiplication is 1 is negative 5. Multiplication is negative 5. Is 7. 7 times 1 is 7. Is negative 5. Negative 5 times 1 is negative 5. 11 minus 5 is 6. 6 times 1 is 6 possible. 0 remains. As always, you create here zeros and factors. Investigate that the x equal 1 below is a 0. This is 0 and the factor is x minus 1. Remember opposite sign, eh? Okay, cool. This is 0 positive, right? And you suppose that we have or 5 or 3 or 1. I anticipate you get 3 is the answer. Because I did before. At the beginning, I don't know. So now, the other factor is 2. I repeat again, guys. You see clear and Desmos. Bring down 1 is 2 is minus 3. Let me focus on that part. This is negative 6. This is positive 1. This is 2. This is minus 3. This is minus 6. This is 0. The second is x equal to, the factor is x minus 2. Okay, and the other 3. I create this example elegant, que es 1, 2, 3. So 1, 2, 3. Bring down 1. Multiplication is 3. 3 minus 3 is 0. Wow. 0 times 3 is 3. This is 4. Make mistake. 1, 2, 3, 0, 0, 0, 0. Hello, I'm crazy. Look. 0 times 3 is 0. This is 1. 1 plus 0 is 1 times 3 is 3. Is 0. Cool. X equal 3. The factor is x minus 3. Remember at the beginning we have degree 5. When you are doing the first synthetic division, you reduce degree 5 to degree 4, degree 4 to degree 3, and degree 3 to degree 2. So actually, this answer is x to the 0, x to the 1, and x to the second. And I highly recommend don't continue synthetic division. No. You copy this expression, okay, this expression is x squared plus 1. Because this part is missing, look, S0 coefficients. This exponent is x to the 0 1, que es this one, and this is 1, x to the 0. But now, this is the last, I suppose que is complex, equal to 0, x squared is negative 1, square root both sides, x is equal plus or minus I. So the other 0 is x equal I, and x equal minus I. And together represent the irreducible quadratic expression x squared plus 1. Let me take advantage of this moment to clarify que normally we can factorization in pre-calculus. In core algebra, no. But in pre-calculus, yes. You can factorization using real. Okay, so now, nice, I like. Real is equivalent to say this polynomial is equivalent to say x minus 1, x minus 2, x minus 3, and x squared plus 1. Because I know that in the real field, I can know factorization this. And the reason is super clear because the solution is imaginary or complex. However, we can in the complex field factorization like that, x minus 1, x minus 2, x minus 3, and here you trick like a difference of a square, but actually it's not difference of a square, it's sum of a square. Okay, always we say it's prime, but it's prime because the solution of this is complex. However, in a complex field, you can factorization like I plus or minus. Wow, I never see before this. We can in the complex field. Let me prove that this is mathematically equivalent. Look, suppose que you multiply, let's do in Bauer. Multiply x plus I times x minus I. You foil. X times x squared. X times minus I is minus ix. Multiplication, the inner is plus ix. And multiplication, the last is negative, 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 negative I squared. Easy cancel. All will happen that we have no coefficient I in the original polynomial. That is the reason the coefficient is real. And negative 1, I squared, sorry, is negative 1, you know. And this negative 1, another negative 1 together is positive. The two possibilities. And the review package of that part, you see factorization in the real field or factorization in the complex field. See factorization in the complex field, we include that part, like a linear factor. So exponent 1, exponent 1, exponent 1, exponent 1, exponent 1. In this case, in the real field, no. Exponent 1, exponent 1, exponent 1, and exponent 2. And this is called quadratic. Quadratic what? Irreducible expression. Cool?
Yes.
Uh-huh. Let me try to find now one example, because you know, like a typical example. Let's try to find. There you go. I found. Okay, can illustrate a little bit the factor complex and the something like that. This is typical. This is a typical example that you see in the test and the lab online. Suppose case given, find. So we need to find completely backward. Find the polynomial of the degree 4. Wow, it's given the degree equal 4. Whose coefficient are real? No, no complex. Uh-huh. And that has the zeros 1 and 1. Ah, 1 and 1 is repeated. Okay, it's repeated multiplicity 2. And give me another. Is negative 4 plus I. Boom. Final answer. Period. Well, degree 4 indicate us that we have 4 0. We have 1, 2, 3, and we need more extra. But I know very, very well that the complex is coming by pair of conjugates. Immediately, I infer if negative 4 plus I is a 0 of the polynomial, I need to discover the other is negative 4 minus I. Que es the conjugate of this guy. That negative 4 plus I conjugate, the symbolic way to indicate conjugate is a hat, The real part stays the same, but the imaginary part no, changes. Cool? Okay, entonces no problema. My function is the multiplication, at least in factory form, the multiplication of x minus 1 squared. Because actually it's x minus 1 times x minus 1. Together, both multiplicity 2 is x minus 1 squared. And the complicated part is the complex part. But okay. I'm using this format. Look, any factor you know is x minus something. Okay, this something maybe is complex, is more complicated, but si es real is 1, so I copy x minus 1. So using this format, I open the parentheses and I copy x minus another parenthesis, negative 4 plus I. Okay, and this is my first factor. I put a bracket to indicate, you know, too much parenthesis, another bracket. The second is x minus 4 minus I. Cool. Close the parenthesis, close the bracket. So our polynomial is formed by 4 factors. 1, 2, 3, and 4. By coincidence, the first and the second is identical, twin brother. But the two last is complex, and it's given 1. I can infer the conjugate. Okay? Wow. It's raining heavy here. Okay, let's continue. All right. Now, let's do the multiplication. I focus in that part. No? Okay. We multiply x minus 4 plus I multiplication x minus 4 minus I. Let's do it quickly. Let's see. X times x is x squared. X times this complex number is minus 4 plus I x. And this complex number times x is minus again, minus 4 plus I x. And the last, is this and this. This negative, positive. Minus 4 plus I times minus 4 minus I. Do you follow me?
Yes.
Excellent. Now I focus in 100%, and that part is super easy because we practice in the first chapter the multiplication for the complex number. Yeah, I learned a little bit how we are doing the multiplication using shortcut. If you multiply negative 4 and negative 4, okay, 16, and you multiply coefficients here, get 1 and 1, yes, 1, plus 1 gets 17. Do you remember that or not? So you want to doing step by step. It's clear or step by step? All right, clear, super. Okay, now the easy part is look, this is x squared. U multiplication here is plus 4x double negative, and this is minus ix. Here is again positive 4x Well, I make mistakes. For sure, I make a mistake because this is the multiplication. This is minus here, right? Let me see. Yeah. Because when you multiply this and this is positive, when you multiply this, and this, and it doesn't matter. One positive. Wait. This and this is negative and negative. If let me erase everything. This is negative here because was the multiplication this and this. It's obvious, but negative. Look at that. So now the second no, the second way of multiplication, this and this get negative 4 plus. So x squared plus 4x is this and this plus ix plus 4x again. Look at that 4x, double negative minus ix plus 17. I suppose you remember very well the answer of this was 17. Fantastic. Look, this is cancelled. The I disappear. No I anymore. No. And we have x squared plus ax plus 17. Oh, final answer. No, final answer. Remember, the only thing we are doing is the multiplication, the complex part. But the real part you forgot because you consider it too easy. The real part is x minus 1 squared. Wow, it's easy. This is x squared minus 2x plus 1. Right? Now, last multiplication both. So basically, I put together this guy and this guy. And now, no foil is 6 combination. 6 combination is x to the 4th power. You need to organize very well your work. You multiply the first time each guy. Bam, bam, bam. 1, 2, 3, 1, 2, 3, 1, 2, 3. In total, it's 9 combination. X to the 4th power minus 2x to the 3rd power. This time is plus x squared. Okay, now plus 8x cubic. This and this minus 16x squared. This and that plus ax. Oh, almost. We finish. Now 17 x squared. I did the multiplication this and this, and this, minus 34 x plus 17 again. Okay. Now identification who is lighter, and that's it. X to the 4 power. Okay, who is cubic? Cubic. But A is positive, 2 is negative. Entonces 6. Square, light term. This, and this. No? Yeah. Entonces 17, 16 is 1. And 1 plus 1 is 2. Cool. Now the rest is super easy. 8 and 34 is 26. And 17 is 10. Wow. And this is my function. This is my function. It satisfies this condition. Satisfy the condition is given at the beginning. We have 1 0 and 1, another 0 and 1, another 0 and this, and another 0 here. Actually, we have 2 real repeated 1 1 and 2 complex. Of course, the complex is coming in pair of 1. Cool.
Yeah.
Well, so we have time to see. Let me see at least is one more example. Let me try to find one good. Okay, that's nice. Okay. One more, the last one. Do you hear very well or no? No good? Wow.
It's hard to hear.
My office is in one terrace. Entonces, en el terrace, the roofing is aluminum. Isolated aluminum. ¿No? It's difficult to hear. Okay, guys. I suppose that we are doing too much today. Okay, entonces no problema. Do you see my face?
Yes.
Okay, so stop. Stop now. Bye bye. We continue Wednesday. We're doing one more and start new topic. Bye, guys.
Bye.